I can demonstrate and predict the sequence of events in the lunar cycle. Moon calendar. Moon phase simulation. Drag Earth or the moon to change the time. So I'm going to drag the moon very slowly, and we're going to see this moon simulation. So at first here we were seeing a new moon, so there's no illumination in the sky. And as we move the moon counterclockwise, you can start to see light on the right, which we call a waxing crescent. And I'm going to speed it up a little more. That waxing crescent is going to grow in illumination little by little. And when we're about a 90-degree angle, we have a first quarter moon, which is light on the right. And as we continue our revolution around Earth, that illumination is going to increase, and we start to have a waxing gibbous. It's a little more than half of the moon, football shape, bulging, light on the right. And we're going to continue our revolution or orbit. And when the moon, the Earth, and the sun become a straight line is where we see that full moon. That's 100% illumination. So now we're going to start to lose that illumination on the right. And you lose a little at a time. So here we have a waning gibbous, and we're losing that light on the right. And we continue to lose the light on the right. And then when we're at a 90-degree angle, we become a third quarter, where we have 50% illumination. We're going to continue our orbit revolution. We're going to lose light on the right, and we become that waning crescent. And that waning crescent continues to lose illumination until we're back to that new moon phase where we see zero illumination in the sky. Let's drag and drop to complete the lunar cycle. So a review, we always want to snap our moon phases. So we start with the sun, the new moon, the Earth, and a full moon. So let's drag and drop that new moon. And we're going to go counterclockwise in revolution. So after a new moon, we begin to get a little light on the right. We call that a waxing crescent. And then when we're at a 90-degree angle, we're at our first quarter where we have light on the right, and it's half of a moon. And we continue. We're going to grow in illumination. We're waxing. More than half will be a waxing gibbous. And then we become that full moon. And that full moon is when Earth, the moon, and the sun are in a straight line. So we're going to grow in illumination. We're going to decrease in illumination now after the full moon. We're going to be a waning gibbous shape because we're still more than half. Then our third quarter is where we have that half of illumination, and we're losing the light on the right. We continue to lose the light on the right, and we're a waning crescent. Let's practice. Each quarter of the cycle takes about 7 days. Let's list those quarter cycles or the major phases. So the new moon is a quarter phase, and this would be our first quarter, and then full moon, third quarter, and back to new moon. These are your 4 major phases, also known as the quarter phases. If there is a new moon on December 10th, there would be a first quarter December 17th. So again, December 10th, we would just count 7 days on a calendar, and December 17th, we would have a first quarter. To move 2 moon phases ahead, it takes about 1 week, 7 days. If there is a waxing crescent, August 7th, what day would there be a waxing gibbous? 1, 2, every 2 moon phases take 7 days. So we would add 7 days to August 7th, and we would have a waxing gibbous August 14th. Look at the calendar here to the left. The moon phase on July 4th, 1776 was a waning gibbous. So we're losing the light on the right, gibbous shape because it's more than half. Predict when the next waxing gibbous moon will appear. So what you would do is you would do a moon dump, so a brain dump on your paper, so you can count every 2 moon phases as 2 weeks until you get to a waxing gibbous. So on the next slide, I prepared that brain dump for us. So if we're a waning gibbous and we want to know what day are we going to have a waxing gibbous on, again, you would have to draw this brain dump on your paper, and every 2 moon phases take 7 days. So from here, I'm going to count 1, 2, 7 days, 1, 2, 7 days, 1, 2, 7 days. So 3 times 7 would be 21 days. So I would add 21 days to July 4th. So 21, 22, 23, 24, 25. July 25th, we would have a waxing gibbous. So I could go here and state waxing gibbous. Okay, today what we're going to do is you guys have a calendar for February 2021. And what I would like you guys to do is drag and drop the correct moon phases here, knowing that the 27th is a full moon. Okay, so on this note, you would probably start with a new moon, and then you would wax. You would put the light on the right. So I'm going to do a few phases and stop from there. So what I'm looking for is a new moon, because I would like to start with that. And I'm sliding over, and here's a picture with 0 illumination. So I have my new moon here and my full moon. So I want to drag and drop these phases. So remember, your new moon your major phases last 1 to 2 days, and your in-between phases last 3 to 5 days. So you want to start off with a waxing crescent, and that waxing crescent is going to last for quite a few days. So I'm going to look for the smallest waxing crescent. I'm looking for light on the right. And this looks pretty good, but I could always flip them around if I need to. And I'm going to scoot over here and see if I can see something smaller. Light on the right, a waxing crescent. These seem to be more or less, it looks to me, the same size. So I want light on the right. Might want to drag this guy over, this waxing crescent, and then probably this waxing crescent. So pretty much anything with light on the right, I'll be dragging over here. And again, I could always flip them around if I need to. Let's see if there's anything over here. I'm looking for a waxing crescent. I don't see any over there. So I'm going to continue. So I'm almost reaching that first quarter phase. So I'm going to scoot over here, and look, here's light on the right. So that would work. And remember, that major phase only lasts 1 to 2 days. Let's see if there's anything over here, light on the right. I don't see any light on the right here. So after this, we want to go more than half light on the right. So more than half light on the right looks like these two. And you start to get the picture. So pretty much what you want to do is, continue to wax. Okay, I'm looking for the light on the right. Light on the right, light on the right. And probably this one. Light on the right. And then here I can see it's probably going to be this full moon. Okay. And then from that full moon phase, you want to wane. So you want to start to lose that light on the right little by little. So it would start off, oh, well, we have room for these too, don't we? So maybe that would be losing light on the right. So this looks like a pretty full moon. And then I start to lose that light on the right. Okay, so I want you to continue with your faces until you reach that full moon. So let's answer some connection questions together. So before the full moon, the light reflected from the moon is a waxing gibbous, right? Because you're a waxing gibbous before a full moon, and that waxing gibbous is bulging almost to 100% illumination. After the full moon, the light reflected from the moon is a waning gibbous. We start to lose that light on the right little by little. The phase of the moon in which we see the entire surface illuminated, full moon. That's when the moon is behind the earth. The date of the next full moon would be 30 days. So every full moon is about 30 days. You can find the date of the next full moon by counting how many quarters you have. Pretend you're explaining to an alien why the moon phases change over the course of a month. What would you say? So first you'd probably start to an alien that if you're on Earth and you look up at the night sky, you see zero illumination because it's a new moon, and the moon does a revolution around the Earth, which takes 30 days. And what you are seeing is the reflection of the sun off the moon in 8 different phases.